Portland cement concrete highways in the 21st century will supply the efficient, long-lasting pavements that the public desires. As part of its ongoing effort to provide the highway traveler with the best roadways, the Kansas Department of Transportation has taken an in-depth look at the air void system in its concrete pavements. One of the methods used to assess the air in Portland cement concrete is the air void analyzer, a machine developed to measure the spacing of the air bubbles in fresh concrete. This spacing factor of the entrained air bubbles is generally regarded as the most significant indicator of the durability of the cement paste matrix to freezing and thawing exposure. The routinely run test for air content is performed using either the rollometer or the pressure meter. Both of these only measure total air content, not just the entrained air content that is needed for an adequate air void system. The spacing factor can be measured on hardened concrete petrographically by the standard ASTM method C457. This expensive test does not give timely information for controlling the fresh concrete. The air void analyzer, known by the acronym AVA, analyzes fresh concrete produced on the project. Typically, the sample is taken behind the paver after all the heavy vibration and manipulation have been applied to the concrete. This gives the actual spacing factor of the pavement concrete. Samples are taken from both the path of a vibrator and the gap area between the vibrators. The sampling equipment consists of a high-speed drill, a device that vibrates a cage to collect the mortar, a 20 milliliter syringe, as well as a plastic template. The drill is turned on, vibrating the cage that is slowly pushed through the template hole and into the concrete. The mortar fills the cage, and then the syringe is extended to capture a sample of the mortar to be used in the test. Samples can be easily obtained in less than 5 minutes. The AVA is a sensitive piece of equipment that measures the air in the concrete by weighing the bubbles that are released from the concrete mortar. To do this, a cylinder of water has a more viscous liquid, glycerol, placed at the bottom using a special funnel. A petri dish hung on a scale rod is suspended at the top of the cylinder and collects the bubbles that rise from the sample. The sample of mortar in the syringe is placed on the end of a plexiglass rod that also contains a temperature probe. The combination is positioned with the end of the syringe at the edge of the cylinder. The plexiglass rod is drawn back to the other edge of the cylinder. The sample is then injected into the glycerol at the bottom of the cylinder. The various parameters of the mixture are entered into this screen on the computer that controls and records the test. The test is started and a command is given to the AVA to mix the mortar with the glycerol using a magnetic stirrer. Note that large bubbles come out of the sample first and rise more quickly than the smaller bubbles. As the test proceeds, smaller and smaller bubbles are released from the glycerol and rise more slowly to the petri dish. The weight of the petri dish becomes less as it collects more and more bubbles. The computer captures this weight every minute and a graph is plotted in real time showing the weight change. After 10 minutes, the bubbles become very small and the weight changes are likewise small. The test continues until there is no weight change recorded for 2 consecutive readings or a maximum time of 25 minutes. By this time, the bubbles are almost imperceptible. These tiny bubbles are the ones that are most efficient at producing a good spacing factor. At the end of the test, the computer program calculates a spacing factor and other parameters. It also produces 2 graphs based on the distribution of the sizes of the entrained air voids. On the right-hand graph, the volume of the smallest bubbles is displayed near the left-hand axis. This information can then be used to adjust dosages or types of both the air entraining agent and the water reducer to provide an adequate air void system. The end result? Portland cement concrete highways that last well into the 21st century.